So here's question 10 from part C. It says oxygen gas is at a temperature of 40 degrees Celsius when it occupies a volume of 2.3 liters. To what temperature in Celsius, so keep in mind that this is wanting the answer in Celsius, should it be raised to occupy a volume of 6.5 dm cubed? Awesome. So this question has a lot going on. So the first thing, all of these have to do with the combined gas law. So let's figure out what it's really asking us. So it gives us temperature, it gives us volume, but at no point does it say anything about pressure. So we can go ahead and assume it's constant and get rid of it. So that means we only have 4 variables we're looking for, V1, T1, and V2 and T2. It says the initial temperature is 40 degrees Celsius, and the volume is 2.3 liters. So what temperature in Celsius? So it wants to know it in Celsius. Would it be raised to occupy a volume of 6.5 decameters cubed? So one thing that you need to know about this conversion specifically is that 1 dm cubed is equivalent to 1 liter. So 1 dm cubed is equal to 1 liter. So that means 6.5 dm cubed is equal to 6 liters. And again, if we wanted, we could turn that 2.3 liters into decimeters, but I always prefer liters since that's the accepted unit for our conversions. The other thing we have to do, even though it's asking for the temperature, the final answer in Celsius, we can only plug into the combined gas law using Kelvin. So we still have to convert both of these to Kelvin. So our unknown answer is going to come out in Kelvin as well. So keep that in mind when you get that final answer. You're going to have to convert it back to Kelvin. So we say 273.15 plus 40. We get 313.15. Make sure your units match. So V1 and V2 are both in liters. T1 and T2 will both be in Kelvin when we're done. Let's go ahead and plug it in. V1, or 2.3 liters, over T1, 313.15 Kelvin, equals V2, 6.0 liters, over T2, our unknown. Again, we're going to go ahead and cross multiply those so we can get T2 by itself. So we have 6.0 liters being multiplied by 313.15 Kelvin equals 2.3 liters multiplied by our unknown T2. We want to isolate T2, get it by itself, and solve for it. So we're going to divide both sides by 2.3 liters. It cancels, so we get T2 by itself. So 6 times 313.15 divided by 2.3. We get 816.91. Keep in mind, our liters cancel, so our answer is in Kelvin. But it wants our answer in Celsius, so we're going to be converting this back to Celsius, which means we're going to subtract 273.15. So we do that, minus 273.15, and we get 543.76 degrees Celsius. So again, the tricky part about this question is again converting it back at the end to degrees Celsius.